NTP. NTP is Network Time Protocol. I did add, well, you guys have looked at this Canvas page yet, but I did add a few links. This is just a list of all the worldwide NTP servers that are run by NTP Pool Project. And I don't know where you can see that. I'll zoom in a little bit. Where'd it go? I stole it. There it is. Just pool.ntp.org. There's over 4,300 individual NTP servers around the world. So click on global and then it takes you to the continent level. Says there's over 1,000 down here in North America. And you click into that. From here, United States, 903 of them were in US.
Oh, wow, that's good.
Click into that. And those are the addresses that you use. 0.us.pool.ntp.org, 1.2.3. 2. For some reason they say is the preferred pool, but see there's only 4 addresses, but there's 900 and some odd NTP servers in the US. So the way that works goes into a round robin type thing. So that was broken down into 4. Same thing again for 1. That's why 2 is a preferred.
As IPv6.
Because my IPv6 address is popping up on it. So yeah, your computer at home, it was a Windows machine, almost assuredly talks to, unless you told it otherwise, we'll talk to whatever Windows NTP server is. Helps if you're doing this, look up front of that, doesn't it? No. At any rate, Windows has their own NTP servers that they run, so they tell their Windows OS to.
EWIN. Is it all Windows?
I would be able to tell you on here, but they have NTP locked down. Additional box. Nope, that ain't it. Set time automatically. Some of these settings are managed by your organization. That means that it's in your domain profile on domain controller. We're going to do this for you, and you are not allowed to change it. But if you go home, you can try it on your own computers. Or if you got your own device here. Mike's got his. Ron, Will, it's like everybody else has just got phones. Which your phone kind of has its own NTP built in. Because
I thought of that. Yeah, that's what I kind of figured. Is there's battery within like some computers or perhaps some phones that when it's even been on for a long period of time keeps track of it. Is that correct?
Your phone is connected to a cellular network.
Right.
And the cellular network knows exactly what time it is all the time.
I see. So even necessarily if that phone doesn't have service, it may still be connecting to.
Oh yeah, it'll still. All phones have to stay connected to a cellular network. What can I say? Cellular network. Because it doesn't matter whether the phone has service or not, you must be able to dial 911.
Oh, right. Yeah, that's true.
So you may not be able to use it to call your girlfriend or your best bud, but you can always call 911 with it.
And or.
Okay, so anyway, you can check out the NTP website at ntp.org, or sorry, ntppool.org, and check out all the different servers around the world.
What is this used for again?
We'll get there.
Oh, 'cause I'm like,
We'll get there. Also, your phone has GPS on it. And one of the things that GPS does is tell you exactly what time its location message was sent. So it knows where it's at, it knows what time to send the message. As long as you can connect to at least 3 of them, it can calculate where you are in 3-dimensional space. Okay, so anyway, since GPS has timestamp information in the signal, you can build your own GPS-powered NTP server. There's a couple of options there. So, this is something fun to try. You do need a GPS antenna that will plug into your Raspberry Pi or whatever you're using to do it with. But anyway, network time protocol is an internet protocol used to synchronize the computer clock with time sources in a network. Belongs to and is one of the oldest parts of the TCP/IP suite. Term NTP applies both to the protocol and the client-server programs that run on computers. David Mills, who was a professor at University of Delaware, developed NTP in 1981, designed to be highly fault-tolerant and scalable while supporting time synchronization. So, why do we need to know have all our computers in sync time-wise across a network? Anybody have any thoughts? Cool.
Well, because if I'm late to turn an assignment and I turn my clock back an hour and then submit it, and you never know the wiser, because it's like, well, maybe my computer's wrong or I'm going out on a limb. But it seems like interactions between people should be time synchronized.
Okay. The timestamp that goes on an assignment that you turn in is based on the server, the OTC or the OTC.instructor.com. the Canvas server, not your local machine, so. Nate?
I was going to say that it's a lot like train stations, but instead of delivering cargo, it's information. If you don't deliver certain information from one station or computer to another station or another computer on time, the possibility that you could lose that data would raise, I'm pretty sure.
Okay, yeah, to a certain extent, that's true. You know, that's why time zones were invented, by the way.
Yeah.
Because train schedules. You know, everybody, every town had their own, well, this is what time it is. And there was no rhyme or reason to it. So, you know, you could be just a couple of miles down the road and it'd be, you know, 10 minutes later or 10 minutes earlier. So, you know, how do you keep trains on schedule like that? You know, it's pretty much impossible. Well, the same thing goes with computers nowadays, especially whenever you're talking about financial information. You guys do any of your banking online? Okay. One of the metrics that the bank server uses is what time is it on your computer? If you are too far off, it'll say, sorry, but your time is jacked, and we're gonna have to fix it, or we can't communicate. One of these days, if you get a chance, manually set the clock on your computer and try and log into your banking app. I bet you it rejects it. How does NTP work? 3-step process. NTP client initiates a time request exchange with the NTP server. Client is then able to calculate the link delay and its local offset and adjust its clock to match the clock on the server's computer.
There it is.
So part of that exchange is, this is what time it is. And one of the things that NTP does, you guys ever heard of latency?
Yeah.
Okay, it takes a finite amount of time for a signal to get down the wire, turn around and come back. And that's latency. You also have what's known as jitter. You guys ever heard of that?
I
No. For latency, I heard jitter.
Okay, jitter is how much difference there is between latency packets.
Oh, from one direction back to the other.
So, well, it sends multiple packets and then waits for them to come back. And of course, it knows which packet it sent, which one comes back. And it measures the amount of time that round trip, that latency is, and then figures out what the difference is between the latency of all of the packets that it's sent. That's the jitter. So the first one is a 3 millisecond round trip. The second one is a 6 second round trip. You'll only do 2 of them, I guess.
Is that
Then the jitter would be the 3 milliseconds, because it's the difference between 6 and 3.
is it because the packet size was different, or
No, it's always the same size.
Okay.
It's just
there's something?
jitter kind of gives you a measure of how busy the network is.
Okay.
On the trace route, yeah, I remember it had like time milliseconds. Okay, so that's what it's keeping time.
Yeah. Let's see. Well, if I can spell. Okay, so it automatically found the closest server to where I'm currently at. I'm gonna go. I'll wait for it to download here.
Oh, so it's actually, I saw this commercial, I just thought it was, oh, it's actually.
is when it gets done performing the download and the upload tests, we'll look for even on a synchronous connection.
Wow,
Speed test.
that's a good upload speed, holy cow.
Yeah, this network. man.
Well, loud then,
The
it's
upload and download will be the same, because a lot of people use the download portion, so.
engine roaring, that's nice.
Well, that's actually almost a gigabit, technically. It's how many?
Wow, and it's showing what the ping is, which is the latency,
Oh, that's cool.
is 8 milliseconds, but it's not showing what the jitter is. They used to tell you what jitter was, apparently they don't anymore.
Yeah, it's connecting to jumping.
Maybe there was no jitter.
There still should be a place that says jitter with no
Yeah.
zero.
It is a possibility that with the rise in updates and the level of skill that a lot of engineers have when constructing networks, that they're able to minimize the jitter so much that you don't even need to test for it.
Yeah, we'll go with that. Okay, so anyway, the client calculates the link delay and its local offset and is able to adjust its local clock to match the clock at the server's computer. Pardon me, all these are sleeping right now, but if you ever walk around campus, look at different computers in the same room. Sometimes they're off by at least a minute, sometimes 2. And they're all connected to the same NTP server. So, any thoughts on,
Some wasn't
That might be.
IPv4, IPv6.
that should not have any bearing on it.
Because they all have a different rate of exchange between either receiving or sending data. Okay.
That still shouldn't matter. Simply because the way it works, it says, here, I want to know what time it is. And then I know what the latency is of the data packets. I can calculate exactly what time it is based off of those 2 pieces of information.
Maybe the computers just need a refresh.
That's possible. As a rule, 6 exchanges over a period of 5 to 10 minutes are required to initially set the clock.
Okay.
Each computer is turned on at a different time unless, you get 30 people in room C. Of course, the chances of them booting up exactly the same way at exactly the same time is also pretty slim. So the computer starts its clock when it gets fully booted. That's when it says, hey, operating system, that's what time I think it is. And then they only periodically go out and say, hey, time server, what time is it? That delay, or that time between ANTP server, what time is it? Is usually set to a minimum 24 hours. Sometimes even up to a week. The clock in the computer can keep the accurate time for, a week or so anyway. Or at least close enough to work. So the ones that you see that have different times on here on campus is because they haven't all updated with the time server recently.
Like they had it updated within 10 minutes or like how long is it?
Several days. Yeah, if you never connect your computer to the internet and you say it's 8:29 a.m.
And never gonna know this.
Well, you can actually tell it the correct time, but
Right.
unless it can go out and say, hey, what time is it now? What time is it now? What time is it now? It'll either gain time or lose time. Simply because it's not designed to be that accurate. Because, everybody's connected to the internet nowadays, they just go find a time server and say, hey, what time is it? Here you go, okay, thanks. Okay. Since they can hold their time for a week or so, relatively accurately, they only need to go talk to the time server every once in a while, once a week, whatever that. Computers on campus, that's determined by the people in IT. But once synchronized, the client updates the clock once about every 10 minutes. That's the default. In reality, do you need to update the clock every 10 minutes?
I don't think you would.
Probably not.
Not the speed of computers these days.
That's why whenever you consider the number of computers that are here on campus, there's 18 or 20 of them in this room alone. That's not counting all the rest of the classrooms in the building and several buildings on campus. Everybody's got their own computer in their office and all that good stuff. Lots of computers. If you have them saying, hey, what time is it? Every 10 minutes, it's going to not bring your network to its knees or anything, but it's going to put unnecessary traffic out on your network all the time. So we only need to know every once in a while what time it really is. So let's only ask once in a while what time it really is. Okay. NTP by default uses UDP, or called user datagram protocol. UDP port 123. So I run an NTP server on my network at home. So my firewall rules say that also run my own recursive DNS server, but firewall rules say that you can access port 123 via UDP protocol on the server at home, but you aren't even allowed to transmit an NTP request to the internet at all. It just blocks the traffic. So the main server goes and talks to ntp.org. Okay, so why is NTP important? Accurate time for all devices on a computer network is important for many reasons. Discrepancy of even a fraction of a second can cause problems. Chances of you keeping all computers on every network accurate to within a fraction of a second of each other is slim. Unless you do ask every 10 minutes, what time is it? Some examples: distributed procedures depend on coordinated times to ensure proper sequences are followed. Security mechanisms depend on consistent timekeeping across the network. That is probably the biggest one right there. NTP is a major part of the security system of your local computer and your network. File system updates carried out across several computers depend on synchronized clock times. I don't know if it still does or not, but whenever you do Windows update, if you set the clock on your computer incorrectly and set it off by a few hours or a couple of days, whatever that is, it won't let you update.
Years ago.
Sometimes it won't let you access websites if the clock's on.
Yeah.
By too much, I recall this happening to me once.
Network acceleration and network management systems rely on the accuracy of timestamps to measure performance and troubleshoot problems. Features include NTP servers have access to highly precise atomic clocks and GPU clocks.
Now, highly precise atomic clock. What is an atomic clock exactly?
An atomic clock at its heart has a cesium atom, probably more than one, but 1 second is defined by, or defined as 9 gazillion something oscillations of
Yeah.
a cesium atom.
Okay.
Cole's gonna look it up for us.
Yeah.
We got that.
Yes, is that why all like the big AI companies now are using graphics cards?
So I've heard
Because all the cores.
The RPM of an electron orbiting around this. I don't know, right?
No, they can, they haven't been able to track that yet. They're getting closer, but
Yeah, we can't even prove that electrons
physically,
exist.
They don't exist,
Nothing exists.
The
They
thing
can-
about
They
electrons,
can jump from one.
valence.
valence shell to
Oh,
another.
no, it's not, valence is only the outer one.
outer.
Right.
But they can jump from one shell to another. But in order to do so, they actually disappear
Yeah, they're one of the
from this
few
one and reappear in that one.
solid,
I hear
not solid.
They
at the
don't
same
jump?
time.
They don't jump, right? Because that's what I was thinking too.
Which comes down to a quantum level at
They're
that point.
metaphysical.
I hear most
Teleport.
quantum physicists don't really consider electrons as actually particles, more like
shells. but
clouds.
We don't know
Yeah.
exactly what position, what level of energy activation.
When you go in,
We know that they have a definite shape, mass, and size, and can move, but we also know that they have the ability to, say, screw all of physics and transcribe between them.
when you find coal.
Because in the process of exchanging energy levels, they themselves release all their energy, gain it back, and then move into either a higher or lower shell.
And the amount of energy that they lose whenever they jump from higher to lower determines the exact frequency of the light photon that is
Put off by that
emitted
jump.
whenever it does.
Excluding valence
Nuclear
shells,
hotel, right?
valence shells are gonna be the
You call it the
hardest to
nuclear
remove, because it
hotel?
takes so much
Where
activation.
they change levels.
Once you get down to the valence shells.
Okay.
Yeah, I just had that like,
Especially some of the.
Oh,
yeah.
I remember yesterday, I can't remember
Yeah,
what semester.
when it does that, it changes that light photon, puts up different colors.
This step to this step to
So you
this
can
step,
tell
and then to this
what-
step.
It's trying to become or something like that.
Well, they can tell how much energy it had.
Right.
Yeah.
So,
Well, if you,
what
so
you got?
light itself is actually.
Hold up there.
Okay.
What you got?
So a second is defined as the duration of 9,192,631,770 periods of the radiation corresponding to the transition between two levels of the cesium-133 atom.
Okay, so all NTP servers use Coordinated Universal Time, or UTC, to synchronize their CPU clock. Avoids even having a fraction of vulnerabilities in information exchange communication, which means that it is extremely robust. Provides consistent timekeeping for file servers. Whenever you're talking about a manufacturing environment, especially food, manufacturing anything that's human consumable, that includes pharmaceutical. If it's just something that they're putting in pill form, it has different regulations than something that can be injected directly into your bloodstream. But they always track everything they possibly can. Temperature, pressure, flow, acidity, alkalinity. You know, there's a whole host of different parameters that they're tracking whenever they're making anything for human consumption. And if the server, file server didn't have accurate timekeeping, you couldn't say that, you know, at this exact time, the temperature fell below a minimum threshold, so now we have to throw out the whole batch. If you're gonna throw out the whole batch, you wanna know why that minimum threshold wasn't maintained. So you can go back through all your systems and find out, you know, did the hot water supply fail, or, you know, did a valve pick up and not provide hot water to the system to keep it hot, or, you know, whatever the situation was. You can, everything's timestamped. So you can go back and say, okay, exactly what anomalies happened at exactly this time. That kind of stuff, so.
So it records the elapsed time as well as you do work.
Well, whenever you're talking about, data historian, SCADA,
It's kind of,
it takes a sample every, whatever their program time slice is. It records all the values that it's supposed to know about. And you do that on every piece of equipment in the building. If they're all synchronized to the exact same time, then you can know when this problem happened over here, we can trace everything back and find the root cause was from something way over there.
that's why the servo asked for synchronization or something whenever we were setting it up.
Well,
Or is it not
when you're
the same?
synchronizing motion axes, it's so that they don't run into each other.
Also, it's not the same.
Yeah, different types of synchronization. Working of NTP protocol, works over the application layer. Remember that guy?
Yeah.
TCP and OIS or whatever.
OSI. Uses hierarchical system of time resources and provides synchronization within the stratum servers. First, at the topmost level, there are highly accurate time resources, such as atomic clocks or GPS clocks. These clock resources are called stratum 0. They're linked to the below NTP servers called stratum 1, 2, or 3, and so on. Servers then provide the accurate date and time so the communicating hosts are synced up to each other. So it's not labeled with the atomic clocks up here. Well, pardon me, the atomic clocks up here are stratum 0. Notice it says or GPS clocks. Every GPS satellite has an atomic clock on board. So the definition stratum 0 is an atomic clock. Stratum 1, stratum 2, stratum 3. They all stay pretty much synchronized with each other. So you can ask any one of them what time it is. You know, as long as you can get to it. Most of the time, you're connected to stratum 2's server. Stratum 3 would be if you had an NTP server on your network and considered a local device. Applications of NTP used in a production system where live sound is recorded. Used in the development of broadcasting infrastructures. Used where file system updates need to be carried out across multiple computers depending upon synchronized clock times. There again, file system update. Used to implement security mechanism which depends on consistent timekeeping over the network.
It's a new year.
Advantages of NTP: provides internet synchronization between devices. That should actually be network. Provides enhanced security within the premises, used in authentication systems like Kerberos. You guys know anything about Kerberos?
No.
It's a security system that systematic key cryptography and a key distribution center to authenticate and verify user identities. So it's basically a lock and key type system. But it relies very heavily on accurate timekeeping. Because if you have the right key, but it's too old, it still won't accept it.
That's understandable. I have stuff like that where like if I have to use online banking and I can't get into my main website, they'll have you send you an email link and it's a key you can use to get in there, but it only lasts for like 30 seconds. Or a minute to 30 seconds.
Provides network acceleration, which helps in troubleshooting problems. Not real sure how it does that. I've never utilized that part of it before. Used in file systems that are difficult in network synchronization. Disadvantages: when the server is down, the sync time is affected across any running communications. Servers are prone to error due to various time zones and conflicts that occur. It's one of the problems with NTP, since there are so many servers in each pool. It is possible for your, hey, what time is it signal, hit two servers at the same time and they'll both respond. And if they don't respond at exactly the same time, then you get garbled communication. So, NTP packets are increased when synchronization. When NTP packets are increased, synchronization is conflicted, which goes back to they're prone to error because getting multiple responses about what time it is. A minimal reduction of time accuracy. I'm not sure exactly what they mean by that either. And worst of all, manipulation can be done with synchronization. So how would they do that?
Manipulation can be
Your favorite term, Cole.
Hacking?
No.
Emailing.
Oh, man in the middle.
Man,
Yeah, most NTP servers are not encrypted. So your NTP traffic goes over the wire completely unencrypted. So man in the middle says, you say, hey, what time is it? The man in the middle says, hey, NTP server, what time is it? And when it comes back, says it's 8:58. But then the man in the middle tells me it's 8:52 or something.
Why would you?
nefarious.
Well, if you're talking
You'll never
about
know what
time critical stuff like banking and federal security, that kind of stuff, you can actually bring a network to its knees if you jack with the NTP traffic. Without getting brain-meltingly technical about it, the heart of every GPS navigation satellite is an extremely precise atomic clock. Satellite continually transmits a signal earthward, which carries messages that consist of, among other things, the time the message is transmitted. As far as the satellite's internal clock is concerned, the satellite's position in the sky and a continually updated pseudo-random code. You might know what pseudo-random means?
Partially random.
partially.
Pseudo-random?
Might as well just say
Just kind of random.
semi-random.
Just kind of random.
Some magic power of God of Wars.
There's actually no such thing as truly random. Not the computer.
Right, man.
That's a spell in it.
Those ones are so
The pseudo-random code is not a cryptographic key, but sequence that can be predicted as long as you know a couple things about it, generated by the satellite. That's how GPS receivers work. Every GPS receiver, when running, also continually generates and updates that pseudo-random code. Every GPS satellite is in medium Earth orbit at an altitude of roughly 12,540 miles. I said kilometers over here, didn't I? Which is the distance at where it is, there is a noticeable lag between when the message is sent and when it's received on the ground.
Yeah.
So not only is the clock on the satellite ticking different than the ones here on Earth, but it's far enough away that we know even at the speed of light, it's going to take a fixed amount of time for the signal to travel.
Yeah, it takes like 0.16 seconds. They're using that 0.16 seconds.
Yeah, depending upon how fast you're going, 1.16 seconds can mean a really big distance.
Right.
The receiver uses times in the message received from multiple GPS satellites, and the pseudo-random code is calculating not only its current coordinates in 3D space, but also the current time. Current time is what we're using to sync our server, but we can use coordinates for other things too if we want. Okay, so basically NTP, make sure that all the clocks on your network and hopefully the rest of the world stay accurate enough to be able to do your banking transactions, make sure that everything is secure and whatnot. David Mills was the one that came up with the idea back in 1981. Some of these questions are going to be on the protocols quiz that we're going to do after class on Wednesday. So, no questions at all?
I mean, how do you connect to these servers if you want to be part of this server and you want to update your time to a server? How would you go about choosing a server and connecting to it?
You would typically choose one that's closer to your geographic location.
Okay. And if you wanted to go through it, would you have to create like you as a client have to connect to it? Like how would you go about it doing that? How would you kind of?
All computers have an NTP client software.
Okay. Yeah. So now the server, do you just go on the internet and?
Yeah, you just point your NTP client at any NTP server. You can literally choose any one you want. It just makes more sense for you to find one that's geographically close to you so that the lag, the latency is as low as it can be.
And you would usually do this when the computer is initially coming into the internet for the first time.
Well, every time you turn it on, it does.
Every time you turn it on, it's automatic.
If there's no NTP server available, it just goes on with about, its life. But if it can connect to one, it will update the clock.